Thank you. He's not going to like the beginning of the talk because it's about 14 years ago. Okay, so my name is Ken. I work for a company called ThoughtWorks. We're a software delivery consulting organization. Normally, I don't even bring that up, but I'm actually going to do something a little different in this talk than I do in most talks. Before I say like what we're thinking about what modern continuous delivery is and should be, I want to give you the stories behind that. Because the why is often more important than the what. And so then you can make a better determination of whether you want to go with our what or your own what. But this is the why. So it's a journey in 4 acts. Act 1, United Kingdom in around 2004, 2005. ThoughtWorks is on a project, and we knew everything. So we're about 25 years old, and we're pretty egotistical. We put out a thing called the ThoughtWorks Radar, Thou Shalt, and so forth. We thought we knew everything. Our chief scientist, Martin Fowler, had signed the Agile Manifesto a few years earlier. He then wrote the blog that defined continuous integration, for whatever that means. People have been doing automated build and test for decades. We're not quite that egotistical. But wrote definitions for that. We created the first continuous integration server with cruise control, unless you count, what's the Mozilla thing? Oh my gosh. There was a build server they did. But it was the first built for CI server. We created Selenium, so we knew all about the web testing, even though it was really horrible in 2005. But we really thought we knew everything. So we go on this project. And according to Sun Microsystems, if you wrote something in Java, you could write it on anywhere you wanted. It would run the same anywhere else. A lot of us would say it's actually meant write once, debug everywhere. But, what have you. And also, this was 4 years before I joined the company, so none of this is my fault. But, much like if anybody was just here for the previous talk, we're talking about plan, build, run. They're developing on Windows laptops. The target environment was a Solaris cluster, but they didn't own any Solaris hardware yet because they didn't need it yet. Okay, so they're developing on the Windows laptops for some number of months. And they did all the right continuous integration things. They were running the proper tests. We're really big on extreme programming engineering practices, so pair programming and test-driven development and all that kind of stuff. And we're pretty proud of ourselves. There was only one small issue. The Solaris boxes showed up, and the software didn't work. Turned out they were doing some things like disk caching and what have you that don't work on a cluster. And things work different on NFS than they do on a local Windows laptop, and so forth. And so the folks on the project, because I was in Canada last week, anyway. The folks on the project wrote a bunch of bash scripts. There was a few thousand lines of bash called Conan the Deployer. And what Conan the Deployer did is every time the CI server was done, it picked up the build, the binary, and put it onto a Solaris cluster to make sure that it worked. So it would run every time, and they were testing the deployment. They weren't testing in production. This was nowhere near production yet, but they were at least testing in that environment, making sure that they didn't introduce any new issues. And so deployment became a non-issue. They had done the deployment so many times that when it did finally get to a point where they were doing production, when they needed to deploy, they were now confident they could just push the button and walk away. So what's the output? The things that we learned and the things that we created to move on with this. 3 people that were on the project, Jez Humble, Dan North, and Chris Reed, wrote a white paper called the Deployment Production Line. Not product line, production line. And presented it at Agile 2006, talking about this process. Jez created GoCD. That's the only time you're going to hear the product I work for. And then Jez and Dave wrote the book Continuous Delivery. And so when we were talking about continuous delivery, it was about delivering to production-like environments as often as possible. Speed and those kinds of things were a byproduct. Okay? It was about getting under a production-like environment to make sure it worked. Act 2. This one is, they're all real stories, but this one, we had a lot of things like this. But again, the one I picked was the one in UK. Very typical architecture for 2000. You had the front end, the application server, and we had good separation of duties and all that neat kind of stuff. And it worked very well. And we were doing what we'll call today traditional continuous delivery. This was literally the year the book came out, so it wasn't traditional then, but I'll call it traditional continuous delivery. So we had a build stage. Somebody does a git push, the CI server does a git pull, builds the thing, puts it in an artifact repository. That triggers a test stage, gets the package, build things once. That's one of the prime rules of continuous delivery. You build an artifact once. We get that artifact, put it on test environments, test pyramid, creates that, tags the artifact repository as this is a version that's past this stage of our process. And then we do a deployment. So get the package, push it to an environment, and then maybe some few smoke tests, but testing in production certainly was not a thing. No observability, all that kind of stuff. It was traditional monitoring at this point. All right, how much CPU are we using, how much, that kind of stuff. We're only doing a lot of business metrics. But the pipeline looked a lot like this. So it looks like any other pipeline. Yes, there's a staging environment. Sorry, Heidi. It was funny because I think Alan asked the question yesterday, who can automatically roll your environments, and then later said who can automatically deploy your applications, and more people raised their hand for the second one. All honesty, because we don't always get everything right for sure, these were hand-rolled environments. The application was going through a pipeline and being tested every time and so forth, but these environments weren't. And so that introduced some issues, which are too much to talk about in 30 minutes. But there was some good here. So the builds were reproducible. Every time there was a commit, a build would run and so forth. A lot of people think, I actually said this in a open space earlier, that the purpose of a continuous delivery pipeline is to deploy to production or get software to production. We would disagree. The purpose of a continuous delivery pipeline is to kill a release candidate. It's to prove the software is not good enough to go to production. To run enough tests and things like that to say, nope, not going. Okay, because you can't prove something's good. You can absolutely prove it's bad. So we're generating the package once as we're supposed to. There was a high-level automation from an application perspective, and we did have a bit of a safety net. They had confidence that when it got to production, it was going to do what it needed because we had very good testing. Now the bad, the monolith. Monoliths aren't always bad. In this case, it was bad. Just because it was very, very large, and the entire system had to be deployed at once. So if you needed to scale it, you had to scale for the whole thing, not just the part you needed to scale and so forth. The browser tests were flaky. It was all Selenium stuff, and by this time we had spun off Selenium. Selenium Foundation went off, and other folks were working on it, and WebDriver had come out and so forth. But they're still pretty flaky. Implicit weights and so forth. Today, they're still pretty flaky. So this was hard. And rollbacks were incredibly hard. We always recommend rolling forward, but this was so big that if we had to roll back, we were kind of hosed. And so output. Sam Newman wrote the book Building Microservices. As I mentioned, it wasn't just this project. There were lots of projects. And so we were like, we have to build smaller pieces. It's one thing to say we're going to deploy every day or for several times a day or what have you. The pieces themselves need to be smaller. Keith wrote the book Infrastructure as Code because we got to stop hand-building environments. That's just bad by every definition of bad. And these are tools that are open source. We don't sell. They're open source, but I'm not going to talk about them. But we created Gauge and Tycho to combat the flaky browser tests. Happy to talk about them later if you want to. Act 3. So this project actually started a couple years ago. It's still going on. But I want to talk about now what we're doing in today's environment, so the modern continuous delivery. And I hope I got through most of the stories. Yeah, good. Because this is going to be most of the time. This is what you all are here for, I hope. So this particular project is a financial services platform. And it's not a monolith for sure. It's microservices and some serverless and some other things. But it's a distributed architecture. They did something that I thought was pretty interesting here, and it's been repeated since then, is these actually don't talk to each other over APIs. So if I create a customer, I don't call the API that talks to the customer service. I actually create an event. And the customer service subscribes to that event. So if the customer service is down, for 20 minutes for some reason, when it comes back up, the events are there, and it can read them and do the things. And so we're trying to put in some robustness. 2 days ago, I would have said resiliency, but Maddie corrected me on that. We're trying to put some robustness in the system so that when, not if, when things happen, we can react to that. And so the modern pipelines now look a lot like the other ones, but they're much smaller pieces of software, and so they're much, much faster. Now, I'm with Heidi that we need to get rid of staging, but there is a case for staging in a lot of things. On-prem, okay? Like you're doing an on-prem project, your product, you're probably not shipping to customers, several times a day. If you're doing continuous delivery correctly, your software should be shippable all the time, so that if you had to push the button, if you have to reply to a security issue or what have you, I can click the button anytime I want. But you're not necessarily really deploying to production for a lot of different kinds of applications. But we still want a production-like environment. So if production is a Solaris cluster, I want to deploy to a Solaris cluster as often as possible. It may not be the same size, okay, but it needs to be look as close to it as possible. It was the idea here. We don't do this often, but we've even seen this quite often. By the way, if a microservice must be an independently deployable unit of code, or unit, or what do you want to call it. Okay, if you have to deploy version 1.2 of this thing with version 1.3 of that thing, not a microservice. Okay, if you have to deploy the same database to two different things, not a microservice. A microservice must be an independently deployable thing. No breaking changes, we version the APIs, etc. But if you're careful, if you're not confident in that, if you want a little bit of security, you can do something like this where your continuous delivery server is taking the latest of all your services. Please don't cherry pick, but taking the latest of all the services, putting them on the staging environment to better know if you broke anything. I don't say no because, again, in today's truly distributed applications where half of these services aren't even yours, you really can't know if you broke something until it gets to production, okay? Because no one's actually trying to buy something on staging and the Visa thing's never being executed. But we want to do these as often as possible. Okay, so the real details, Act 4. There are some things that I think are mandatory that you might not think about very often. It is very hard to write a good, even if it's not microservice, even if it's componentized or whatever, a distributed application with a traditional, 100-person development team or what have you. And we can throw the walls and call the teams whatever you want. But these large teams and stuff don't really work in this environment very well. The communication needs to be APIs, not ticketing systems, okay? And so this is where we come into products over projects. Okay, so this is DevOps to me. DevOps is about the sharing and cross-functional teams and those kinds of things. DevOps isn't automation. Automation is part of DevOps. But this is doing the DevOps. So I take the person with some systems knowledge, and I take the person, the tester and whatever, and they're on the team. If there had been a Solaris person on the team in 2005, the continuous delivery book would not exist. Because they would have said, whoa, I'm not a Java expert, but that's not going to work. Oh, okay. And by the way, it also would have saved 2 months of rework fixing all that stuff. Okay? That Solaris expert's not going to become a Java expert. The Java programmer wasn't going to become a Solaris expert, but they could do the different things. Also, I loved the point in the talk before this one where funding models are different. So now, with cloud and everything else, projects end. Products, when they end, that means the product's dead, it's gone. Okay, so funding model is different too. So let's talk about the continuous delivery pieces. I mentioned, and I think everybody's on board with this, 9 years after the book came out, one of the key things about continuous delivery is we only build a thing once. If you're building a jar file, you build it once. You store that one, that's get passed around, and so forth. We're passing a lot of things over the wire. The new build artifact these days, Docker, Docker, Docker. Okay, so we're not actually passing the image around anymore, but we're building something, we're putting it into something like a repo or what have you. We're not fans of the latest tag on containers. Okay, you'll never see one on any of our products because we want you to know which specific version you want. Okay, and latest, what does really latest mean? And do I really want that one? And did I want to upgrade automatically and so forth? But you can. So now the pipeline looks a little bit more like this. I make a change in version control. I run the build, test, what have you. That pushes an image to a Docker registry. Okay, please don't have that be Docker Hub. Public registries, attack services, security, etc. But it goes to a registry. And then the later stages in the pipeline, they're now doing things in a more descriptive manner. So kube control, kube cuddle, whatever you want to call it. I'm not actually taking it and copying a jar file up to production and then doing things. I'm just running an apply command that tells, Kubernetes or whatever to upgrade to the next version. And so the CD server is executing the commands at the right time, making sure that it's using the right versions and all that kind of stuff, but it's not actually passing the artifacts around anymore. This is only going to be 2 minutes of the talk, but it's going to be 100% of the questions. We're huge fans of trunk-based development. There was open space about it earlier. Heidi talked about it, so she saved me 3 minutes off my talk. We do everything, trunk, master, what have you, but we also still believe in things like code reviews. So even if, like on the Go team, the developers are sitting next to each other, when they do merge to master, the way they do it is a pull request. And the person next to them looks at it right then and merges it, okay? But it's still a pull request, so it's still eyes on it. It's still, code review, that type of thing. But we do constantly go to trunk. Trunk is always deployable for us. And that's where the things like feature toggles come in. That's where you can say, if a feature's half done, but I wanted to be able to deploy from master, then I have to have a way to turn that feature off in production. And feature toggles, feature flags. There's another thing for libraries underneath that aren't forward-facing things like branch by abstraction. There's all different kinds of ways you can do this, but you need to keep your software always in a releasable state. I do a talk sometimes called "It's not continuous delivery if you can't deploy right now." And I mean that literally. If there's not a system you can walk up to and click a button and deploy to production, then it's not quite CD yet. So a lot's been said about these, and I'll have some resources at the end, but move on. Testing. How does testing change in today's distributed application world and so forth? A lot. So again, everybody's familiar with the test pyramid. Book came out, I don't know, 10 years ago or so. We run your unit tests, less service tests, UI tests. And a lot of people say, well, this is dead now, because in distributed applications it doesn't work. We don't think it's dead, but we think it's more complicated. Okay. So, we have unit test integration tests, but now we have component tests. And we have contract tests, okay? So you're not allowed to make a breaking change in a microservice. If you have a service and it has an API, and that's version 1 of your API, if you're going to make a breaking change, you deploy version 2 of the API alongside version 1. The consumers keep using version 1 until they're ready as the consumer, because you're a product now, right? So you have to go out and say, hey, use the new version of our API. They decide when they want to go to version 2. So I need to have contract tests to make sure that people didn't break my APIs. And believe it or not, we still like end-to-end tests. But not a lot of them, okay? And I would more likely call them customer journeys. So if we're gonna have to deploy, if we're gonna have to test in production or what have you, I wanna test it like a user's gonna test it. I wanna take a web browser, go to a URL, click a button, add a thing to a cart, put in a fake credit card number. All the credit card processors give you numbers that will run a real API command, return success or failure, but it won't actually charge anybody. Okay, and I want to make sure I can actually buy something from my website. I don't care that I'm only using 80% of the CPU if I can't buy something from my website. And the only way to do that's as a customer. Deploying. How am I on time? Okay. Lots of different deployment methodologies and so forth. But the one thing that we're seeing the most that we really want to encourage people to do is it's declarative deployment, so desired state, if you will. So things like Helm and other tools, sorry for the YAML, okay. But what you're actually doing is you're telling your production environment, this is what I want you to look like. I want you to have this many pods or whatever of version 1.1 of my API, and there's still consumers on 1.0, so I need this many pods of that, and, et cetera. You're telling it what you want it to look like. You apply the Helm chart or Helm install or what have you, and Kubernetes picks it up and does the things. But again, I'm not putting it in my CD server how to do a deployment. And that logic is in the declarative deployment so that it's in source control, and I can code review it and do all the other things. So some strategies that brings up. The default pretty much in a lot of Kubernetes, not 100%, okay, but is the whole rolling update. So we tell it, okay, we had version 1, now we want version 2, and it goes in through and replaces pod by pod. That works well, zero downtime, et cetera, but it's still all or nothing. It's not instant all or nothing, but it's still all or nothing. The rolling updates by default will go through, and you can change that, I know, and so forth, but that's the default. Blue-green. Blue-green is very popular. So you have version 1 running. You deploy the new stuff to new stuff, which cloud makes it easier to do that now. You do some smoke test, whatever you're going to do, make sure that works. You change your load balancer or your routing over, and now you're pointing at V2. Okay, blue-green is nothing new. In this environment with these architectures, I'm a big fan of canary deployment. This would be my recommended default anyway. A canary deployment, anybody not familiar with the term? Okay, so the advantage here is that I'm putting the new application on a certain percentage, and now I can test in production. I can see what users do. You know, our systems are really, really good until we apply users. Okay, so I want to apply users, but I don't want to apply users to the whole thing. And I want to see what they do, and if they broke it, and if there's an edge case, and if they're, you know, et cetera. And by the way, more than anything, I want to see, did this make my business better? So I changed the way the feature works. Did my sales go up or down? Okay, if they went down, then we roll it back. We take it out. Kill the canary. Okay, because, you know, again, you know, I think Heidi said it, our company is, we can pretend we're as altruistic as we want, but we're here to make money for the most part. If you didn't see Michelle's talk yesterday, watch the recording. One of the hardest things is database changes with zero downtime and so forth. So we want to deploy the database stuff out of band. So you have version 1 running, the app's using version 1, no breaking changes in your database, everything's forward. Okay, so I can't rename a column. I have to add a new column, read from both or write to one, et cetera. Again, watch Michelle's talk because he goes into a lot more detail, so I took the detail out of mine. Saved me another 5 minutes. But the idea is there, you migrate the database to version 2 with version 1 of the app still running against it, then put the app version 2 on there that uses the new fields. So you do them out of band, you don't do them at one time. Again, what the cloud gives us is these dynamic environments. If you do need a staging environment or what have you, you don't have to have machines running anymore. These all can be dynamic. The elasticity of the cloud is really a key to a lot of this. But I can stand up testing environments. I can stand up other things. I guess I lied a little bit about not mentioning GoCD. It's open source. If you do a pull request, the first thing that happens is we spin up 40 boxes in Amazon, and we run 12,000 tests in about 8 minutes. So you'll know about that fast if the unit tests are going to fail. Could not afford to do that if we couldn't just spin them up on demand. So dynamic environments, please do look at taking advantage of them as much as you can. They actually will save you money. Don't tell Amazon stockholders that. Monitoring. Monitoring changes a lot today. And in a lot of ways you might not be thinking about. So this is kind of the old school, if you will. Not that, you know, it works. But we deploy a thing, we get output, et cetera, and we, you know, do pretty charts and so forth. What we really want is observability. We want to be able to query our systems for state and query our systems to ask the questions of things that we don't know about, et cetera. Like the example here, what was it? I didn't write this slide. You know, query events, ask questions, et cetera. A thing came up in the open space earlier. You know, what if a memory leak gets to production and what have you? We should be adding monitoring and observability to the pipeline. This should not wait until production. Okay? If the observability is built into our applications, then while they're running in the functional test stage, we can be gathering this data. And we can find out more about how our applications behave before they get to production. Because yes, we're going to have to test in production, but why not get visibility sooner? The tools are very, very good at this. And so let's not wait till they get to production to apply them. There's one thing that's always missing from this circle, and you know, the continuous delivery, these are the steps, and it always is missing from DevOps. And so people came up with the whole DevSecOps. Okay, where's security meet in all this? I know there's open space about this yesterday. Some of us old grumpy people object to terms like DevSecOps because we think it lets DevOps off the hook for security, and it's not. Okay, I don't think of DevOps as developing and operate, or it's developers and operators. I think of it as developing and operating verbs. That includes requirements analysis and security and monitoring and getting paged and et cetera. It's developing and operating a system. So where does security fit? Okay, cliche time, security is everybody's job. Okay, but it really is. Because now we have pipelines that if we pass all our automated tests, can have our new code into production in minutes, and we get hacked 3 minutes later because someone's watching, they got network scanners going constantly. You have to think about this from the very beginning. Luckily, again, there's good things out there. Okay, so there's ways of vulnerability planning. So Sneak's just one example. I can have in my pipeline, not can, should, have in my pipeline something that as early as possible says, am I using any packages with known CVEs? Okay, there's tools, I don't care if you're using Java or Ruby or what have you. The talk yesterday where 97% of hacks were from, whatever that number was. That's just scary because that's easy to put in a pipeline. Twistlock's kind of cool. What it does is you generate a model of what you expect your application to do. I expect it to change files in this area. I expect it to use this much resources, et cetera. And it creates a model of that and alerts you on alteration or deviations from that model. Hey, you got this application out there, and it just wrote to a directory it's never written to before. Okay, and these run in real time. Secrets management. We can't put our secrets in GitHub, please. Don't do that. Even encrypted or whatever. So we really have to do about secrets management. Now, I'm going to tell you right now, I told Maddie I was going to tell you this. When I say cross-functional teams, I ain't kidding. I know nothing about this work, how this works. Don't ask me questions. Okay? But I know you have to do it. I don't know how Vault works, but that's the whole idea behind a cross-functional team. Is that, when we talk about these things, you need to do the secrets management in a safe way. So your containers don't actually have the secret. They have things like a role ID or a token, and they get it. And by the way, they're revocable per container or what have you, so we can deal with hacks and such. But this needs to be, what you need to be thinking about this during continuous delivery, not just in production. So epilogue. In the future. I strongly believe teams have to be structured to own small pieces. One of my dad jokes I tell all the time is you only have to change one thing to do the DevOps. Everything. Okay, this is all very, very intertwined. If there really only is one thing, it's probably the team structure. And I'm not going to go with two pizza and all that, but it's the structure of people that think of this as a product that they own. They're going to come up with the ideas. They're going to nurse it when it's sick, but they own the thing and it's small pieces. Today, it's Docker and Kubernetes are eating the world, okay? Are there options to these? Absolutely. I'm old, I use Solaris zones, okay? But today, this is what you're looking at until it's not. And it will change, so again, you want to be agile and reactive and know how to change these things. But right now, today, when we're advising clients, we're like, yeah, feel free to go all in on Docker and Kubernetes. Just, it's going to change. I'm unikernel, serverless, I don't know. You have to test in production. Heidi talked about it too. Especially, now these distributed systems where we don't even own all of them. So we're using SaaS products for certain things. We're using, credit card authorizations if you're in that business. You're usually booking travel through Hilton's APIs, whatever. You don't have access to all the things to test the application. So you have to test in production, but you can own it and architect for it. So you can do canary deployments and reduce what Microsoft calls your blast radius to make it so that when something goes wrong, it goes wrong to a small percentage of people. And if you are web-based and so forth and you can deploy many, many times a day, your fix is to roll forward a very small amount of changes. So it's okay. Now, don't do this if you're Visa. Definitely do this if you're cat memes. So think about your risk, okay? But you're going to have to test in production with these highly distributed applications. I can't stress it enough. Security is everybody's job. And I know it's cliche, but it really has to be. And again, cross-functional teams. I'm not saying all your developers have to become security experts. Okay, one of my best friends is a guy that sits in a dark room and does intrusion testing to his own company. He actually had to get a thing signed by their lawyers so they wouldn't make him go to jail for it because he's technically breaking the law. And I still need him. He's not in the pipeline. I need that person, okay? But there are things we can and should automate. So if you want to do, I saw a couple cameras, but if you really want cameras, and I'm going to send out the slides later. Some of the resources I've talked about, there's the Agile Manifesto, some stuff on Martin Fowler's site, some stuff from Honeycomb about observability, et cetera. Because I know this was a lot of incredibly high level, probably not actionable, frankly, information. But, I mean, the point of the matter is that right now for modern stuff, it is about decomposing and doing small pieces. It is about testing everything in production. It is about being practical with your tests. So we don't need to say we don't have any end-to-end tests anymore, but we don't need 3,000 of them either. Okay, you definitely don't need functional tests that are user story acceptance criteria. Please don't ever do that again. Okay. With that, thank you.